Hi everyone, today we're going to be taking a look at the solutions for the mysterious crash discussion board. So, our first problem is that we are assuming a group of 100 passengers travel. So we want to discuss this data for the worst possible case of weight distribution, leading to a tail-heavy plane. What would the total weight difference between the two ends of the plane be? And is it relatively safe to say that almost 100% of people would be within 2 standard deviations of the mean? We will assume from the available data that the weight of people in the United States is, on average, 172.2 pounds, with a standard deviation of 29.8 pounds. So let's move on to the solution for that problem. So the worst possible case scenario for this data would be having all lighter passengers in the front half of the plane and all heavier passengers in the back half. So if everyone was within 2 standard deviations of the mean, the front 50 passengers would each weigh, and this is the equation that I have here. So we take the mean weight of 172.2, and then we're going to subtract 2 times that standard deviation of 29.8. So our answer for the weight of each of those 50 passengers in the front is 112.6 pounds. For the back passengers, we have the exact same equation, only now we are adding rather than subtracting that same amount, the 2 standard deviations of the mean. So each of the 50 passengers in the back half of the plane will weigh 231.8 pounds. So the total weight of the front half of the plane, we're just going to take that weight that we found, 112.6, and multiply that by 50 for the 50 passengers in the front. That means the total weight of the front half of the plane will be 5,630 pounds. And then we're going to do the exact same thing for the back half. So we're taking that average weight of 231.8 and multiplying by 50. So our answer will be that the back half of the plane will now weigh 11,590 pounds. So the total weight difference between the two ends, we're just going to take the larger number, subtract it by the smaller number there, and our answer is 5,960 pounds. So that'll be the total difference, which, as you can see, is a very large difference. It's actually over double the weight in the back of the plane as opposed to the front. So you can kind of start to get an idea of how this would cause a tail-heavy plane. Next up, we're going to be looking at part 2 of our problem. So same scenario, but now we are considering how the baggage is distributed throughout the cargo hold. So in an ideal setting, a bag weight of 50 pounds is the maximum weight allowed. So that would be an extreme for any given flight. In other words, we would expect most people to have bag weights well below the maximum. Since, however, we are dealing with a normal distribution, we will at the very least assume that very few people have bags that have weights near the described maximum. That is, a bag weight of 50 pounds would likely be 3 standard deviations away from the mean. So let's suppose that the bag weights are found to be normally distributed with a mean of 25 pounds. So we'll start with that, and we will find out what the standard deviation of bag weights would be. We will describe in words what this value means, and then is it realistic given what we know about bag weights. We will then look at what the standard deviation would be for bag weights of 20 and 34 pounds and discuss whether we think those are more or less realistic. So let's take a look at the solution for this part. So we know that the mean weight for the bags is 25 pounds in our first calculation, and that 50 pounds is 3 standard deviations from the mean. So to calculate that, we are going to do 25, that's our mean, plus 3 times the standard deviation equals 50. So simplifying that down, we've now got 3 times standard deviation equals 25, which means that our standard deviation would be about 8.33 pounds. So given what we know about normal distributions, this would mean that approximately 68.3% of bag weights would fall within 1 standard deviation. So that would be within the following range here. We've got 25 minus 8.33, which is 16.67 pounds. and 25 plus 8.33, which is 33.33 pounds. So that would be, we would have 68.3% in that range there. And we would have about 95.4% of bag weights falling within 2 standard deviations. So that would be this range here. We're calculating it the same way, but of course we are now doing 2 standard deviations rather than 1. So that gives us a range of 8.33 pounds to 41.67 pounds. So let's take a look at those other means that we had discussed and see if we think those are more or less realistic. So for the 20-pound mean, we would still want the 50-pound weight to be 3 standard deviations from the mean. So we're going to calculate it the exact same way. We've got 20 plus 3 times the standard deviation is 50. So again, simplifying that down, and we get the standard deviation of 10 pounds. So that means that approximately 95.4% of our bag weights would again fall within 2 standard deviations of the mean, which in this case is going to be 0 to 40 pounds. So that does give us a pretty wide range. Let's take a look at what answers we would get with the 34-pound mean. So again, we are calculating the exact same way. We've got that 34-pound mean, and we want 3 standard deviations from the mean. So as we simplify that down, we get a standard deviation of 5.33 pounds. So with that mean weight of 34 pounds, approximately 95.4% of bag weights will now fall within the range of 23.33 pounds to 44.67 pounds. So I know it can be hard to say which of these scenarios is the most realistic. So the thought process that I had behind this was, just kind of thinking about my travel experience in the past and how I do believe that the majority of passengers like to try to stuff as much as they can into their suitcases, just so that they have, everything that they may or may not need on their trip. So I lean towards the fact that a heavier mean might be more realistic. However, in this particular scenario with everything that we discussed, you could see that the heavier we make the mean, the smaller the standard deviation is. So that means we're going to have a smaller range for those bag weights. So for that reason, I did choose the mid-range mean as being the most realistic. So I said that the 25-pound mean is going to be the most realistic of these 3. All right, and then moving on to our third and final problem. Our problem here is going to be, in reality, what would you expect the shape of the distribution of bag weights to look like? Would it be normal? Would it be skewed in one direction or another? Would it be bimodal, having 2 peaks instead of just 1? Use your intuition to propose a reasonable possibility. So of course, this is a pretty subjective question, but the way that I approached it was, again, thinking about my experience in the past, and as I mentioned in the last problem, I do believe that a lot of people try to cram as much as they can into their bags without hitting, that weight where they would need to incur extra fees. So I do believe that the shape would be most likely skewed towards the heavier end or the right side. All right, so that is all I've got for this problem. I am more than happy to answer any questions, so please reach out to me if you have any additional questions or would like any help. Thank you all so much, and have a great day.